Hello and welcome to another Rubber Ducky video. This time, last we left off, we made a matrix class which had getters, setters, and the basic operations of matrices such as addition, multiplication with a scalar number, and multiplication with a matrix. Also, I had a show function as an utility that allowed us to print out the matrix in the console. Now, in this video, what I'm going to do is to create some new helper functions for utility purposes, such as get column, get row, set column, set row, of course the transpose operation that we didn't implement last time, and the sub matrix utility function. So transpose will be an operation rather than an utility method. Let's begin with this one, which seems will be quite easy. So this one returns a matrix and doesn't get any arguments at all. And since we did that many times before, all we gotta do is create a result matrix which has the m and n of the original matrix, and from I and j across m and n, what we do is that we set the I and j elements in the j and I elements of the original matrix. Of course, the new matrix should have the reverse dimensions of the original. So this will give us the transpose matrix of the current one. So now, in order to get the submatrix, how do I define the submatrix? Because that's a kind of a tricky thing, and it's gonna be quite useful when later I'm gonna ask the class to give me the determinant of the matrix. So submatrix, public matrix submatrix, has two arguments, m and n, and it returns a matrix with the row and column with the mth row and nth column removed from the original one. So how's that gonna be? Let's see this. Get m and n, but the resulting matrix will have one less row, one less column. Now, for 1 through result get m, I will have to copy all the elements until I reach the m argument, which I seem to be in need of different counters in here, which means that I will define here int I2, int I of the result, let's call it that, and int j of the result, or maybe of this, because I want the I inside the for loop to express the resulting counter. So what we do is, in here I'm gonna open some brackets and go like if I equals m, the original counter, I I this plus plus. And don't get into this for loop. Just jump ahead. Continue. Don't do anything. And I'm pretty sure I should put an I this plus plus in here, but this will make the for loop a bit more unreadable. So I'm going to put it in the end of the for loop. So every time this is completed, I this gets increased. And when it reaches the mth row, it will be increased, but it won't enter the for loop. Now I will have to do the same thing in here. Namely, I will have to check if j equals n, then j this plus plus, and skip the row, skip the column, and each time you write down also increase j this. So this will have, so I should have I this and j this in the this get invocation, which will return us the submatrix. Hopefully I'm not missing something important here. So best thing to see if it works is to try it out. You know what? It's kind of hard to have matrices which are a bit complicated right now. So let me make another utility function, a static function, public static matrix. No, it will be a constructor, public matrix, which receives an array of doubles, which I will call V, and this array of doubles will be the new value, values equals V. So I think the smartest thing to do is to put this a bit more high up together with the other constructor. And also I should check if all the columns have the same size, because in Java you are allowed to have two-dimensional matrices where columns have different lengths. So I equals 0, I less than v dot length, and I plus plus. If, and also I should store the initial value. So int dim equals v dot v of 0 dot length, and since the 0th value is in dim already, I should begin from number 1. So if dim is different than the v of I dot length, return, can I return in a constructor? I don't think this is right. I'll probably do it with a flag. Boolean flag equals true if, not if, but flag equals false, something went wrong. If flag equals true, values equals v, else values equals no, which should be the original default value, but doesn't matter. So after this error checking, I should be able to come down here and create a pretty matrix like this, like new matrix mate, and mate will be a two-dimensional array of doubles, which I will initialize like this. No, like this. So it has 1, 2, 3, 4, 11, 12, 13, 14, 15, no, 21, 22, 23, 24, and semicolon. This, let's see if it works right. I'm gonna press now Control, Shift and F6, and it works. Great. So what if I create a new matrix Y, which is a matrix of ones, and it has 3 rows, 4 columns, and a Z matrix where Z is x dot add y times multiply. Maybe I should rename y to times, not just multiply. It's a bit more easy to say. And let's see how z goes. 0, 1, 2, 3, 10, 11, 12. The operations seem to be alright. Great. Now let's see if I can invoke the submatrix function. No, before the submatrix function, let's try to invoke the transpose function that we wrote. That's good. And submatrix, let's remove the 0, 0 line and column, and it's well, no, that's not right. But I'm already in 13 minutes, and I think it's gonna take quite long to upload to YouTube. So wait for the next video where we will solve this bug. Thanks for sticking with me.